Suppose we start with the function f of x is equal to x squared, which is graphed here, and this red quadratic shows the graph of f of x equals x squared. So what's true all along this is that if we take the value of x and we square it, we will get the value of y. So for example, when x is equal to 2, y will be equal to 2 squared, or 4. When x is equal to, let's say, negative 2, we square that, we also get 4, which is why our quadratic is symmetrical around the y-axis, because the value of x squared and the value of the negative x squared are going to be the same. So suppose we now create a new function by dragging the vertex of this function somewhere else on the coordinate plane. We're going to create a new function called g of x, and it's going to have this equation, a times x minus j squared plus k. And we'll talk about what that means in 1 second. So suppose, for example, we drag this so that we've dragged the vertex now to the point 3, 1. Well, the equation of our new quadratic is equal to x minus 3 squared plus 1. The reason for that is that we took this point 0, 0, where x was equal to y, or y was equal to x squared, and we dragged it over to 3, 1. So it's no longer true here that y is equal to x squared. In fact, what's true is that if we subtract 3 from the x value of this point a, we get 0. And if we square that and then add 1 to it, we'll get the value of y here. So thus our new equation, x minus 3 in parentheses squared plus 1. This is called the vertex form, and the reason is because we can immediately tell what the vertex of this quadratic is by looking at this equation. So the vertex is going to have a value of 3, 1. So we subtract the x value of the vertex from x, we add the y value of the vertex over here. So for example, we drag this over to, let's say, we drag it to 3, negative 2. So now what's true is that if we subtract 3 from the value of x, square it, and then subtract 2, we'll get the value of y. Now notice here, let's take this point on our original quadratic, and we slide it to 2, 4. And again, what was true there was that y, 4, is equal to x squared. So 4 is equal to 2 squared. For this quadratic, that's no longer true. What is true, however, is that if we take the value of x and subtract 3 from it, which gives us 2, we then square that and we subtract 2 from that, we're going to get 2 squared, or 4, minus 2. That's going to give us the y-coordinate of this point here. So what's true for every point along this red quadratic here is that x minus 3 squared minus 2 is equal to y. Or in other words, the value of the function is equal to x minus 3 squared minus 2. And again, immediately from this, we can tell what the vertex is. The vertex is going to be positive 3, negative 2. So if we were to slide this over here, we end up with x plus 3 squared minus 2, because now we have to add 3 to the value of x, square that, and subtract 2 to get the value of y. Over here, again, we have, let's say, the point, we have negative, well, let's say we're going to put the vertex at negative 5, 1, and what's true anywhere along this red quadratic now is that x plus 5 squared plus 1 is equal to y. So for example, this point right here, negative 3, 5, if we add 5 to the x value, we get 2. Negative 3 plus 5 is 2. If we then square that 2, we square that 2, and we get 4. And then we add 1 to that, we get the y value, or 5. So that's going to hold wherever we drag this thing. And it's going to hold for any point along here. So now we're saying x minus 5 squared minus 3 gives us y. Well, as we move the original point on the quadratic, we can see that there's a corresponding point on the new quadratic that is shifted 5 units to the right and 3 units down. 5 units to the right, 3 units down. That's what we did with the vertex. We shifted it 5 units to the right and 3 units down. Okay, you'll notice that we have this slider here too. But before we get to that, I want to look at something called the expanded form. So if we were to take g of x and we were to multiply out this x minus 5 times x minus 5 and then subtract 3, what we would get would look like this. Okay, let me move this out of the way first so that we have a clearer screen. Okay, so the expanded form here gives us x squared plus 6x plus 7. So if we multiply out x plus 3 squared, we're going to get x squared plus 3x plus 9, or x squared plus 6x plus 9, and then we subtract 2, we end up with x squared plus 6x plus 7. So let's look at a couple special cases here. Okay, so we start again with, let's say, the quadratic with the vertex at 0, 0. Well, our expanded form is just x squared. Notice what happens if we keep the vertex on the x-axis. So we have that the x value of the vertex is 1, the y value is 0, so our equation x minus 1 squared plus 0. But that means that all we're doing is, to get the expanded form down here, we're squaring x minus 1. We're getting x squared minus 2x plus 1. If we move over here, we get x squared minus 4x plus 4, x squared minus 6x plus 9, x squared minus 8x plus 16, etc. If we then go up or down from there, you can see the only thing that's going to change in the expanded form is the constant term, the term which we represent as c in the ax squared plus bx plus c form. Okay, if we just have the vertex on the y-axis and slide it up or down, all that happens in the expanded form is we get x squared plus or minus some number which is equal to the y value of the vertex. Okay, so you will notice that in the form g of x, we also have this thing right here, this variable or constant called a. Well, we can change the value of a, and let's look what happens as we do. Okay, we get this new quadratic, that is, as a increases in size, we get a narrower quadratic, whereas if a is between 0 and 1, it's wider, and when a is negative, it flips down. Okay, so let's drag this somewhere else, change a, and see what we have. Okay, so now we have that a is set to 2, which means that our new quadratic is narrower than our original quadratic. And what we see here is that the form of the equation is g of x is equal to 2, our value of x, or our value of a, excuse me, times x minus 3 squared plus 1. So the x minus 3 squared and the positive 1 still stay the same, even though we've now changed the value of a. In the expanded form, however, we now have to take that into account, and so we now have 2x squared minus 12x plus 19. As a changes, you can see the expanded form will change, but the vertex form up here, the only thing that's changing is this number right here. And again, as a increases in value, our quadratic gets narrower. And so what we're saying now is that, let's say we have this equation, a is equal to 2 times x minus 3 squared plus 1. Now to figure out the value of a, we have to take, let's say we have a point on this quadratic, let's say right here, c. And we'll say that c has a, let's see what the value of that is. We'll look at so it has a coordinates of 4, 3. So what we're saying is now we have to subtract 3 from x, which gives us 1. We square that, which again gives us 1, double it, which gives us 2, and we add 1 to get the value of 3. If we were to change a to 3 here, we would get instead an equation that looks like this. So now we have this point 4, 4. So we subtract 3 from it, we square that, but then we multiply it by 3 and then add 1 to get our value of y. Again, in the expanded form, we multiplied x minus 3 by itself. We squared it. That gave us x squared minus 6x plus 9. We multiplied all that by 3, and then we added 1 to get 3x squared minus 18x plus 28.